All right, welcome back. This is James Camp, your friendly computer science instructor at Lee College in Baytown, Texas. Today, our topic is the introduction to Lesson 5, loops. So, if you imagine a program that needs to do something, and do something, and maybe do something else, and then do them again, we might have a decision point here, a decision diamond asking if we're done yet. And if we're not done, we cycle back up and repeat that. Eventually we will be done, and the program continues on. You can pretty well see why this structure is called a loop. Okay, it forms a continuous circle that loops back on itself. Okay. So, how does this work in actual code? In the computer stores a series of instructions, and it usually will follow one instruction, then the next, then the next, then the next, unless it's interrupted in some way or told to do something like a loop. And in old programming, this is kind of about how we used to code this. Is do an instruction, do an instruction, do an instruction, and then we'd have a statement like go to X, where X would be a marker that we put in right up there. And so the code would run this instruction, this instruction, this instruction, up, go to X. We come back up here and we repeat, and it loops. This is still probably what the assembly language code or the machine code that your program gets compiled into is going to ultimately look like, is that the computer needs to know at some point to run back to an earlier instruction. But that said, this is not how we write loops anymore. There's the newer in vogue way to do it, and it's been in vogue for about several decades now, so it's not like this is a fashion trend. The newer way to do this is to write your programs with what we call structured programming, where we have up, loop, boop, boop. And these three lines belong to the loop, and then we come back out and program keeps going. And in this case, the program flow goes here, here, up. We see a loop. We're going to do this, loop back some number of times or until some condition is met. And then eventually we move on to the rest of the program. Okay. How do we do this in C++? We have the keyword while, and then we have parentheses. And inside the parentheses is what we call a loop condition. Okay, some condition that evaluates to either 1 or 0. Where have we seen that before? The if statement. Okay. While is very much like if, except that while keeps going. As long as this loop condition doesn't cool down, doesn't turn out to be false. So I could say while hot, cool down. Okay. And that would be a valid C++ loop if we defined hot and cool down. But that's the basic idea, is that while a condition is being met, we're going to do something that in some way modifies that condition. Eventually, it won't be hot anymore, and we'll move on to the next step in the recipe or whatever that is. We also in C++ have a loop called for. It also has parentheses, but it's got 3 parts to the parentheses. It's got an initializer part and a loop condition part and a part that modifies the loop variable. Often it's a plus so that we step through all of the possibilities one at a time. But it doesn't have to be. It could be plus equals 10 and we could count by tens, or it could be times 2. You could have a for loop that steps through things in multiples of 2. So the C++ for loop is very, very flexible. And you're going to find that is both the power of it and the thing that you hate about it, because the more powerful a tool is, the more ways there usually are to mess it up. Okay. So that's my introduction to loops and looping. I hope you get an idea of how everything fits into the big picture here, and you can proceed on now to lesson 5 and my lectures on loops and things. As always, good luck and happy programming.